Well, hello, everybody. Welcome to my talk on container defaults and why they're a hacker's best friend. My name's Eric Smalling, but I don't really have a lot of time to talk to you. We got 15 minutes. So I'm going to hit this quick. I'm a software dev. I'm a dev advocate at Sneak, and been doing Docker stuff and things like this for quite a while. So let's get into what we're going to talk about today. Quickly, I'm going to show you an app, and Samuel's reminding me I got 15 minutes. Show you an app. I'm going to show you how that app could be hacked. And then we're going to get into how we can prevent this by not using defaults in our containers and our clusters. So first of all, let's talk a little bit about containers and what are the challenges developers like us face as we start to containerize our applications. Mainly, it's this increased scope of responsibility we have because we aren't only having to deal with our application security now, like good coding practice and libraries, vulnerabilities and libraries, things like that. We're now picking up things that are added by that Docker file and Kubernetes files and whatnot. Things like operating system concerns, packages. What's my base image bringing along for the ride? File system permissions, users, all that stuff that we've always known about. If any of you've been doing development for any length of time. But they've been handled for us usually by sysadmins or security or middleware teams, or somebody usually dictates to us, here's the users you have to use, or they coordinate with you at least, and they set it up for you, and then our applications would get deployed on top. Well, now we're it's on our shoulders now, because that Docker file and that Kubernetes YAML and whatever else we're using is sitting right in our code base with us. Infrastructure as code is here, and it is what we're doing. And honestly, I can speak for myself. I had a lack of expertise around this area of hardening my infrastructure, my operating system or my container environment for security. And on top of all of this, velocity is king. We are all in a DevOps, CI/CD kind of a world now, and getting things from ideation to production and adding security tooling to the developer's point of view and practices to what we do day to day can't be done in a way that slows down that velocity, because business is not going to accept that. And we can't just ignore it, because throwing it over the wall, that's how you get yourself into a security exploit situation. So enough slides. Let's get on and let me show you this demo. So first of all, if I can get my focus on the right screen, just set the scene. Let's say we're at a company that has this legacy app, and it's just a Java EE app. And in this case, it's our to-do list app, which is critical, cash cow for us, makes a ton of money. And a couple of years ago, we containerized this. We lifted and shifted it into a container, and we're running it on a Kubernetes cluster in-house somewhere. Now for this demo, I'm just running locally. I just got a Docker desktop Kubernetes running so I can show you this simply. Here's the Docker file that we're using, and you can see it's a multi-stage Docker file. The first stage builds our WAR file, and the second stage is just based on the official Tomcat image. Now, any of you who are Java or Tomcat users may know that's a hella old version. Well, a couple of years ago, when we did lift and shift this, that was what we were running in production. And if it ain't broke, don't fix it, right? So that's what we're still using. The rest of it is just copying artifacts and config files into that Tomcat container and running it. So let's see what this looks like from a hacker's point of view. So if I'm a black hat, I am most likely aware, especially if I specialize or if I'm focused on Tomcat this week, I'm going to be looking at pages like this, which is the official Tomcat vulnerabilities fix list. So you can see all these versions of Tomcat and what's been fixed from a security standpoint. And if I scroll through here enough, you're going to start seeing things like denial of service. There's a lot of those. Remote code execution. In fact, there is a remote code execution vulnerability that I can demonstrate right now for you. This is CVE 2017-12-6117. Rolls right off the tongue. Here's our vulnerability database. This is similar to MITRE. This is just the CVE database. Our site adds a little extra info that our analysts put in. But it goes into talking what it is. Now, I could dig into this, figure out how to exploit this. But luckily, there's a couple exploit DB links. And one of those has a Python script that does a proof of concept. This Python script basically has two functions to it. One will check to see if a given IP endpoint is vulnerable, and the other will put a simple exploit out there. So I've copied those into a couple aliases. Let me get to my terminal. and I'm going to run check. This is going to hit my local Kubernetes cluster. And imagine if this was real world, this would be going out and hitting endpoints that are available, just looking, kind of like the old war games war dialer, right? And just looking for IPs in this case that might be vulnerable. And it found that mine is. And it put a little proof of concept JSP out there. So let's come back over to my browser. And just to show you that we are on that version of Tomcat, I've got the sample servlet coming up as 8.5.21. And now if I put that POC JSP in there, you'll see there's this page with a bunch of A's. Now, I just injected that JSP. That was not there, I promise you, before I ran that check script. Now, a bunch of A's is not nefarious, really, but the fact that I could put a JSP in, that's not good. Let's go back to my terminal. I'm going to run the other half, the other alias that runs the demo exploit. And if I change this POC to PWN, I've got a nice little form here that I can type anything I want into. Let's just type date. I just ran the date command inside the environment that Tomcat server is running at. Let's see. I can see my environmental variables. Shrink the font just a little. This gives me a lot of good information. I can see that, looks like I've got a Java application, most likely Tomcat. Okay, well, I know I'm in a Tomcat server. Kind of knew that already anyway from the exploit. But here's the Kubernetes port. That is interesting. That means I'm in a container in a Kubernetes cluster, and I could start gathering information here. But this isn't really as interesting as what else can I do? I can look at the Etsy folder. Let's see, who am I? Oh, I'm root. That's even a better bonus. Let's see if I can cat Etsy password. I sure can. Now, this is a container, so this isn't the host's at password file yet. Let's see if I have write access. Let's see if I touch something in a folder I shouldn't be able to touch in. Okay, that doesn't return anything, but if we do the lsltr on Etsy, we scroll to the bottom. Sure enough, I just created a foo file in the Etsy folder because I'm root in a container, and I have a read-write file system. So as I keep on doing things, I'm finding more and more about my environment that I'm in. Let's see if I've got access to outside world. Let's try to do the good old curl of Google. And I got a 301. That tells me I most likely do, because that would be the normal response from Google. And I also have curl. Now, at this point, most people are just going to go curl their hacker script from S3 and start Bitcoin mining or something on your node and eat up all of the CPU and memory they can get at, because that seems to be the game a lot of people play. They could start trying to pick at that Kubernetes endpoint. I could actually, since I'm root, I'll bet you appgate is available to me. And yes, it is. In fact, the Debian app servers are visible to me. So I can install anything that's there, or I can install my own Debian app repo. I can start installing my own software. And I could put nmap on here, start poking around in your network. All sorts of things I could do. Now, at this point, if you've ever seen a sneak presentation, often we'll start talking about how to be proactive as a developer and scan for things like this ahead of time. And I'll scroll back just to show you. You could scan for this, and this is not a sneak ad. You could do this with many tools. This is a container scan, and it's showing all the vulnerabilities of fixed versions, and it's also showing better base images I could be using to not bring in so many vulnerabilities right from the start. Don't have a lot of time to get into that, so we want to get to that default discussion that I was talking about. So go back to my slides. So practicing defense in depth by not using defaults is important. And yes, I'm running out of time. So first things first, you saw that I had curl, I had appgate, I had a whole bunch of tools available to me that I didn't have to do anything to get. Minimize that. Minimize your images, your final images footprint, to not give tools your application doesn't need to a hacker, because anything they've got to leverage is one less thing they have to try to ship onto that box to use. I was recently at a meetup where a bunch of penetration testers were talking about living off the land. When you get on a box, try not to trigger intrusion detection by using just tools that are on the VM or the container or whatever already. And those tools were already there for me. Understand how Docker layer or image layers work. I don't have a little time to go into the minutia of that, but just know that just because you remove a file in your Docker file that layer, that image, that layer, that file will still be present on the host system's layer directories. And if somebody were to break out of the containers file system through a errant volume mount or something, they could possibly get at those files, even if you think you're removing them. Practice good build strategies. Look at other tools. Like if you're a Java shop, look at Jib. That's a great way to build images that are very tiny. Use multi-stage. If you're using Docker files, look at multi-stage. You can narrow that final image down as much as you can. Also choose good base images that don't have a ton of stuff in them. And finally, you could spend an entire week, and KubeCon just did, talking about secure supply chain. Just basically, in a nutshell, know where your content is coming from, your images and what's in them, and don't be pushing things to servers that aren't built by audited automation. Eric Smalling's image should never be getting pushed to a test or production server because you really don't know what all is in it. At runtime, some of the things I could have done to stop a hacker. In fact, this exploit was old, right? There are newer RCEs out there, and there's probably 0 days out there. You can mitigate or make it harder for a hacker to leverage those by doing some of these things. Don't run as root in your container. Create a user. Look to see if that base image has another user you can switch to, whether it be in your Docker file or in your deployment Kubernetes YAML. Use another user other than root, because even though you're contained, as you saw, I had extended capabilities in that container to do things more so than I would have if I wasn't a privileged user. Don't use privileged containers. Now, this is a default in Kubernetes and Docker. Don't turn that on. Just if you're hacking around trying to get something to work and you use privilege to do it, don't check that in. That is dangerous. You're giving root access to devices and things on the host machine. Horrible. Linux capabilities. The original, the Docker crew and the container engine development crews have found a good set of limited Linux system capabilities, which are system calls you can make from your process, that are good for the majority of applications out there. But for business apps, things that a lot of us work on all the time, you probably don't need any of those. You're probably not manipulating the network stack. You're not doing things that your app process needs to call to the kernel to make changes. So deny them all and just add back the ones you need. There's a lot of blogs out there you can search on to figure out what capabilities do you need. But again, you probably don't need any. Read-only root file systems. When a container starts up, it puts a read-write layer in there for mutability. If you're a good 12-factor app, you shouldn't be mutable in the first place. So make it read-only, externalize your persistence so that you're not having to have read-write. If I didn't have write access, I couldn't have curled anything down. I couldn't have appgate installed anything. It really puts a clamp down on what a bad actor can do in that container. Also pay attention to your volume mounts and do sane things there. Similar to the secure supply chain point I made earlier, deploy from known sources. Defaults inside of Kubernetes. Secrets are great. They you can use them for your credentials and your whatever, but make sure your cluster operator or admin or whoever builds your clusters is encrypting them at rest. The default in Kubernetes as of today, especially if you build with kubeadmin or kubeadm or something like that, is not. It's just base64 encoded in etcd. So if a bad actor gets in and gets access to your etcd cluster, they've got all of your secrets. If you're in a managed Kubernetes cluster, a lot of them are starting to default to using their own KMS systems to encrypt those, but just make sure of it. Use RBAC. By default, Kubernetes ships with a ton of security knobs and switches to turn. They're not turned on necessarily. You have to provide your own RBAC rules. Nobody can tell you what role-based access control your application needs, so you need to implement that. Security context. These are settings on the pod and containers that tweak a lot of the things we talked about in the prior slide. Much of the many of these things, we actually have a quick blog that link to it is there to it. I'll tweet this slide deck out and you'll have the link. But that goes into like 10 of these, this cheat sheet, right? And goes into these security contexts. Pay attention to them, learn them, love them. Network policy, by default, this is not turned on either. And make sure you're using a CNI provider that implements network policy. But a lot of people think it's complicated. It's not. It's just rules about how pods can or can't talk to each other. And I'm a fan of turning on a deny all zero trust policy and then just allow list only pod. This pod can talk to this, or this namespace can talk to that. Make sure you open up DNS if you do that, because you'll break your whole thing. And finally, enforce all of these things. Use something like OPA with Gatekeeper, or use Kyverno. Or if you're using pod security policies, they're great as well, but they are deprecated. So to make sure you're paying attention to the pod security admission stuff that's coming to replace it, or using one of these other tools. And with all of that, we made it to the end. and I have seconds to spare. Thank you so much. Eric Smalling on Twitter. I'll be tweeting these slides. See you.